the beginning, and then how you got into crypto and blockchain.
So by way of summarizing, I have been at various times an evolutionary biologist, a human genome mapping library sequence analyst, a professional musician with 2 songs in the top 40 radio in the United States, an information architect at Amazon, an epidemiologist, a rare book librarian, and an ecological economist. And I might be missing a thing or two. But despite the seeming diversity and plurality of these different domains, there have been a series of constant threads and themes that have made them, from my perspective at least, all a unity.
All right. So, that's interesting. I mean, and you mentioned so many things. I was looking at your LinkedIn as well. We've obviously had a few meetings, which were all very, very interesting. So I want to dig a little bit deeper into each of the different phases in your life. And like we mentioned, you can perhaps dig a little bit into how each of these phases has led to where you are today and the kind of work that you're doing today with Archain. So you started off as an evolutionary biologist at Yale, and you talked about, during our interactions, about how cultural and tech evolution very, very closely mirrors or follows biological evolution. So could you talk a little bit more about your experience as an evolutionary biologist and how that relates to tech in today's context?
Absolutely. So in college, I declared probably 6 different majors, but they all had in common that I was trying to find a framework to explain the complexity of the world, be it natural or human. And when I really dug deep into evolutionary theory and evolutionary biology, I realized that there was a possible foundation for a grand unified theory. So my final year in college, I declared my major to be biology, and I studied very hard, and I took the GREs, and I ended up getting a full scholarship to Yale University for 8 years of study in evolution. And my goal was to study evolutionary biology in the context in which the mathematics, the theories are best developed, which is in biology. But my goal was to then apply what I had learned about evolution in its biological context and apply them to linguistic evolution and technological evolution, evolution of objects. If you look even at musical instruments, there's branching and speciation of wind instruments or string instruments. There's branching and evolution of computer languages, and a lot of the underlying dynamics of how entities speciate within technology or culture or language are the same mathematically at a abstract level as they are when new species evolve. The other thing that I learned a lot about in my 8 years at Yale was about animal behavior and sociobiology, and how organizational behavior might be an example of animal behavior, in a sense, that many of the same dominance hierarchies and tribalisms and whatnot that happen in many species, many social species, applied also to organizational behavior. So, in a sense, thinking about the world from an evolutionary perspective and an animal behavior perspective has kind of been a foundational framework about how I think about things and how I solve problems and how I understand my place within human systems.
So that's fascinating. So, if we focus on the first point that you mentioned, could you take an example to show how the branching of tech languages and biological evolution has a relationship?
That specific thing I haven't really thought deeply about, or that specific example of the evolution of computer languages, for example. But let's just talk about human languages.
Sure.
In human languages, a lot of why human languages diverge has to do with geographic isolation. That parties that originally spoke the same language when they're geographically isolated tend to, through random mutation in pronunciation and injection of new words, they gradually separate. So if you think, for example, of the English language and how the original version of English that landed in different territories gradually diverged from the pronunciation and specific words that are used. And a really interesting example of this that ties into a biological case is that the language that is spoken in the version of English that is spoken in the southern Appalachians of the United States is actually extremely close to the version of English spoken by Shakespeare in terms of the words and the metaphors and the pronunciation. And so the Appalachian version of English has been a sort of geographic isolate that captured historically what the language used to be like.